I've been thinking a lot about holes. What are holes? Where are holes? What happens when we put two holes together? Can we count them? Today, I'm going to try and convince you that holes can get a lot more weird than you'd probably imagine. Here's a question. How many different types of hole can you think of? There are square holes and triangular holes, but they're both basically the same type of hole, really. I mean, can you think of two completely different types of hole? Whatever that means. So one thing you might think of is to notice that when you dig a hole into a mountain, then either you stop at a dead end, or you go all the way through. These are two different types of hole. It's not easy to tell which is which without having to go through them. We can tell the difference. Like this one is a through hole. I'll call these ones dead ends, and these ones through holes. Take a look at this cave, for example. We have a dead end over this way, but if we come this way and through here, we have a through hole. Or what about this? There's a through hole that comes down here. We have a dead end in that direction, then another through hole down here, a dead end, and there's one more through hole just down there, and a through hole up there. You might not have thought of holes as having different types before, but I hope it's a bit more obvious what I'm talking about. There's something else we should talk about before we properly get started though. Another idea that you might have is that a hole is when something's missing, like that. Or when something's supposed to be there but it's not there yet, like this jigsaw piece. For example, look at this t-shirt. You might say that it has two holes in it, and it's quite clear which two holes we're talking about, right? These two. But today I want to count all the holes. I want to look at this as one entire object. Or have a look at this statue of a hole I made. It's meant to have the through hole in the middle, but now it's got bits missing out of it as well. I want to look at the whole thing and consider all the holes today. Take a look at this building. It's got a hole through here to get into the next room, a hole in this wall to get into the next room, and a hole to get out the other side. But if we look at the entire building as one object, then it's really only got one hole through it. It starts at this end and it comes out the other end. I mean, sure, it might be a bit wiggly as it goes through, but it's still only really one hole. You can't just talk about holes as a place in space. They're more just each object has a number of holes. Okay, so we have two types of holes so far. We've got through holes and dead ends. Let's start off by trying to count dead ends. One way to think of a dead end is as empty space inside an object. And to count them, we can just kind of fill them up, and then just count how many pieces of glass we have at the end. So we've got one here, we'd put one here, that's one there that we'd fill in. Okay, what about something like this? Is that a dead end? Yeah, it is. I mean, you have to kind of walk at it from this angle, but that still counts. Okay, what about something like this? It doesn't really look like a dead end, but it still kind of is. You just have to approach it like with your head tilted downwards. So I'm still going to count this as a dead end. One thing to notice is that dead ends can be very shallow, but that's still fine, I think. This still counts as a dead end. But then it starts to get harder. Like, what about this? Or this? Or this? Or even this? Like, these aren't really dead ends, are they? I think I'm going to call these dips, and these as dead ends. So what's the difference? Well, one idea you might have is that a dead end can hold water. That's a pretty good way of defining it, although you might have to rotate the shape to hold the water first. Or maybe you want to say you have to be able to put some sort of flat cap over the top of it. But I'd like to be able to count multiple dead ends coming off each other as well. Like, take this hole. I want to say there's one dead end over there and one dead end over there, but we could just fill the whole thing with water. It gets a bit more tricky, and actually finding a way of counting that these are two different dead ends is not as easy as you might think. To see what I mean, try flying around a Minecraft cave and counting all the dead ends. And even if you can count the dead ends, trying to come up with a rule that counts how many there are, that can actually be really tricky. Okay, so we saw a few dead ends, but they were pretty hard to count. We also had a few dips, that I was calling them, but we're not going to look at those too much. Now I want to move on to through holes. Okay, let's start with something 2D, a piece of paper. How many through holes are in it? Well, actually it's only 3. These are not through holes, they're more like the dips that we saw earlier. If you want to be able to count them, remember that a through hole you always have to be able to draw a circle around it. For example, this spiral doesn't have a through hole in it, but if we put a block here, then now it does. You can have through holes in 3D objects as well, like this, or even ones that curve, like this. Oh, no, that's not a through hole. You can have through holes that go round and come back out the same side they started at. And you can even have through holes that go through, round, and then join back out to where they started. Even though this only has one entrance, it still counts as a through hole. But if we remove these blocks, now it's just a fancy dead end. One way to see this is if you were to try and draw a circle around this part of the tunnel, it's fine. But as soon as we break through here, now it doesn't quite work. We can draw a circle around the whole thing, but then it just leads to a dead end. If you're confused, try imagining putting a piece of string through the hole, and then holding both ends from outside. If when you pull it, you can get it out, then it's a dead end. There's nothing really stopping you. But if it gets blocked off somehow, that means it's a through hole. You'll have to let go of one end of the string to be able to pull it all the way through. Okay, so far I've avoided what is probably the biggest and most famous question when it comes to holes. How many holes in a straw? We've talked about why I want to say it has at least one, even though technically nothing's missing. But is it one or is it two? If we count this as two different holes, then actually a lot of things become a lot nicer. For example, this shape over here. It just feels like it makes sense to say that this has 3 holes, right? Or take some weird shape like this, for example. It just feels like it has 1, 2, 3, 4, 5 holes. You can't say this is a different number, can you? Well, the thing to realise is that you're really just looking at the openings, the bit on the outsides that look like holes. But that doesn't tell us what goes on the inside, and that's what I want a hole to say. For example, if I block off this middle bit, now I've blocked it off and turned it into 2 different dead ends. So I want to be able to use holes to describe what happens on the inside of a shape as well. Or, for example, take this one. It looks like it has 4 holes, but what if I go inside and board up this bit? Now I've turned this into 1 hole through here, and another hole through here. Does this still have 4 holes in it? What if I break this? Haven't I added another hole? So that's why we won't be counting openings. They just tell us what's going on the outside, and we want to know what's going on the inside too. So here's the question. Can we have a shape which has a through hole, but only 1 opening? And the answer is yes. For example, this one that I showed earlier, right? It's only got 1 opening into it, but it's still got a through hole. So basically, this straw has 1 hole. But then, how do we describe something like this? The answer is quite simple. First, you fill it in, and then you just count how many holes you have to do to get back to what your original shape was. So there's 1 hole through here, and then here's a second hole through here. So there's 2 holes in this shape. But hang on a second, there's something funny going on here. Like, I could count this as my first hole, and then put my second hole here. So where are our 2 holes? Which bit counts as which hole? Well, that turns out to be a question that doesn't really make any sense. Okay, let's go back to when we only had 1 hole. This shape still has a hole in it, right? I mean, it looks like it has a hole in it. And you can still kind of draw a wiggly circle around the outside of it. But where actually is the hole? Or what about this shape? I mean, it looks like it has 2 holes in it, right? 1 here and 1 here. Then you look more closely and you realise that what you thought was a hole was actually a dip. But then maybe these 2 holes are just 1 hole that's connected together? Well, it's the same thing as the last one, right? It's just 1 rope that's had its ends tied together. So it still definitely has 1 hole through it, but actually being able to say exactly where this hole is and where it goes, that's just not a question we can do. And if you thought that one was weird, this one will blow your mind. This is actually one of my favourite shapes. This is a rope that's been tied in a knot. You can see it kind of starts here, comes down here, round here, but instead of connecting back up again, it goes back and then through itself and then connects back up. It would be impossible to untangle this mess back into like a circle, but it still has 1 hole in it. I won't go into the details here of how you'd show that, but being able to say exactly where this hole is, that's basically impossible. So the fact is, this shape has 2 holes. Where are these 2 holes? We just can't say. We just know that every time we count the holes, we always get 2. The main thing to remember is that holes are a property of the shape, not just a place in space. Okay, here's a quick test. How many holes in this snake? Well, you have to be careful. You might be tempted to fill in this bit, but then you'd just be filling in a dip, remember? And dips are very different to through holes. That's not what we want to count at the moment. How about this lovely pair of trousers? Well, if we do our same method, we'll get 1 hole through there, and a second hole through there. And we might be left with this space in the middle, but that's just a dip. That doesn't really matter too much. How about this 4-way junction? Well, same process as before. We've got 1 hole through here, and then another through here, and a final one through here. So that's 3 holes total. Another way to do it is to put a wall in the middle. So you split this into 1 hole through here, and a second hole through there. And then if we break this wall, we add a third hole. So 3 holes total still. Let's move on to some weirder shapes. How about this one? Well, let's fill it in and then count. We have 1 hole here, 1 hole here, and then finally 1 hole here. So that means this shape has 3 holes total. In fact, it's basically the same as our 4-way junction over there. Okay, what about this shape? So you might be tempted to do the same thing as last time, right? We've got 1 through hole here, 1 through hole there, and then 1 bit in the middle to take out to make our final hole. But that doesn't quite work. Like, we'll end up with a hole inside our hole with this bit that goes through. So, can we get around it? The answer, of course, is yes. This is 1 hole here, and I know this hole has a dip in it, but that's fine. This is still just 1 through hole. And then we can remove our second through hole. So this has 2 through holes in total. And hopefully that makes sense. Like when we were talking earlier, we were saying that hoops are kind of holes when you can draw a circle around the outside. And this is basically 2 hoops that have been joined together. So it makes sense that it should have 2 holes. Okay, what about something absolutely disgusting like this? This is 2 hoops, but this time they're intersecting. Well, hopefully your intuition should say that this has still 2 holes. We can't exactly say where the holes are, and it looks like they have holes in the middle of the holes. But it still works fine. Remember, holes are a property of the object, and if it's just got 2 hoops in it that are connected, that's always just going to have 2 holes in it. You can still check this one yourself if you wanted to. Remember, holes are a property of the shape, not just a place in space. So far we've seen dips, through holes, and dead ends. But are there any other types of holes? Yes, there are. Have a look at this balloon. It's not solid, it's got a hole in it, right? It's not like this ball is solid. But is this a dip inside it? No. Is it a through hole? No, definitely not. And is it a dead end? Well, no, because it doesn't have any entrance to it. This is actually a completely new type of hole, what I'll call a sealed space. We can create shapes with as many sealed spaces as we like, we just have to join more and more balloons together. So this has 3 sealed spaces. These are pretty easy to count, as long as you can see inside them, that is. Can you have both a sealed space and a through hole in an object? Yeah, of course you can. You just have to join a hoop to a sealed space. Easy. Well, what if I put a through hole in a balloon? Does a through hole plus a sealed space equal a dead end? The answer is not really, no. Here's another example. Here's a shape with 2 different sealed spaces, and I'm going to make a hole between one sealed space to the next. But is that really a hole? We started off with 2 sealed spaces, and now we've only got 1 sealed space. So, if anything, we've removed a hole. Okay, now I've made the hole bigger, and now you can't even tell that there was a hole there to begin with. It just feels like it's one big hole. So the answer is these really are 3 different types of hole. I know it's tempting to try and build one out of the other, but I want to consider these as 3 completely separate things. Okay, next question. How many holes in this hoop? Well, 1, right? And it doesn't matter that we're inside a giant glass box. The hoop still has 1 hole in it. Okay, what if I connect these 2 together to make one big object? Well, I want to try and convince you that this still is a through hole. You can start here, you can go through, and you can get back to where you started. It satisfies all the definitions, right? Draw a circle around it, that's fine. You could push a piece of string through it and pull on both ends, that's fine. So this is both a through hole inside a sealed space. It's kind of 2 different types of hole in one. Let's look at it a different way. Start off with this shape. And I've got a glass ceiling on the front, but that's just to show us what happens inside. It's currently completely solid. Okay, now I'm making a sealed space inside. So now we've got 1 hole inside this object. Now I'm going to cut a through hole that goes through here, round and back and ends up here, like this. Now we have a hole that goes all the way around. This is still actually a through hole. Confusingly enough, we just need to edit our rule of a through hole. As long as it starts and ends in the same bit of space, then that still counts. So this shape here has both a sealed space inside it and a through hole. That's just kind of weird, right? Incidentally, if we add another through hole through the center, so this one starts like at the outside space, goes through, ends up in outside space, this now becomes what we call a torus. It's like a donut that's hollow, and this has one sealed space and then two different through holes. One that goes through here, and then one that goes through here. Neat. Okay, let's recap. So far we've seen dips, which are like this. We've seen through holes where you can go through them. We've seen dead ends, which almost you can go through them, but they end. And we've seen sealed spaces. Is there any others, and how can we know? So the first important thing to realise is that there are two very different categories of holes. We have superficial holes. These include dead ends that we've seen, and dips like this, or like this. These are dips. These just kind of affect the outside of an object, and they don't like go all the way through an object. Whereas the second category of holes is structural holes. These structural holes go all the way through, or are just entirely contained within a shape. These are a very different type of hole to superficial holes, right? Now, superficial holes, well, we've already seen that they can be pretty difficult to count and tell the difference between. Whereas structural holes are arguably a lot more important. These things we can count. In fact, many people, when they're talking about holes, they really mean structural holes. Structural holes are way more important. It's fine if you don't understand the difference quite yet between superficial and structural, but keep this in mind and hopefully it will become clear a bit later. So the big question is, how many different types of hole are there? Are we missing any? And the trick to doing this is to look in different dimensions. Okay, let's start off in one-dimensional space. If you're not familiar with 1D space, it just means we can just go forwards or backwards. So everything just exists on one long line. And shapes in 1D space are basically just long sticks. So what would it look like if we put a hole in this stick? This is what we'd call a one-dimensional hole, or just a gap. And we can put as many gaps as we want. We can do this, we can do this. And in general, the amount of gaps, 1, 2, 3, is just the number of pieces minus 1. So 1, 2, 3, 4 pieces minus 1 to get the number of gaps. Okay, let's move up into two-dimensional space. We can still do our one-dimensional holes, gaps, like this. We just have to cut through more blocks now. It's just separated the shape into two different pieces. Or our gaps can sometimes get stuck, and then it's only like half a gap, or what we were calling a dip. This is a one-dimensional superficial hole, whereas this is a one-dimensional structural hole. Hopefully that makes some sense. Gaps can actually do some weird stuff. We can go round and come back out the same side we started on. As long as it divides it up into two different pieces, that's fine. Or we can even go through, round, and then come back into the gap. It still divides the shape into two different pieces. And in general, the amount of gaps in our shape is still just the amount of pieces minus 1, which feels pretty weird when you're in 2 dimensions, but it actually makes perfect sense, really. It's just the amount of bridges that you have to build to connect the whole thing up. So here we needed to use 3 bridges, and now the whole shape has been connected. So this shape has 3 gaps. What about this? Is this a gap? No, it's not. We've just put the 2 ends of a rope near each other to make it look like a gap. So this is what we'd call a superficial gap, or a dip. But obviously there's something else that we can do in 2 dimensions, and that's making a 2-dimensional hole, or what we would be calling a through hole. Okay, here's a challenge. What about this shape? Well, it's definitely got a 1-dimensional hole because it's split into 2 pieces, but it's also got a 2-dimensional hole. In fact, since we live in the 3rd dimension, we can just take this piece and move it out here somewhere. Now it's more obvious that this has a 1-dimensional hole, a gap, and a 2-dimensional hole, a through hole. So to recap, so far we've seen gaps, which are 1-dimensional and structural because they go all the way through. We've seen dips, which are 1-dimensional but superficial, in that they don't go all the way through. We've seen through holes, which are 2-dimensional, like a circle, and structural, because they go all the way through. We've seen dead ends, which are 2-dimensional, like a circle, and superficial, because they don't go all the way through. So look at this bridge, for example. It has a dip, a through hole, a gap, a dip, and this one's also a gap. It divides this piece from this piece. Okay, let's have a look at 3 dimensions. And the holes kind of work the way you think they should do. Like this is still a gap, because it cuts the piece off from each other. And this is still a through hole. We've looked at through holes a lot in 3D, so hopefully you have some idea of how to count them, but this is one through hole. But now we can also remove a 3-dimensional shape from the inside of a 3-dimensional shape to get a sealed space, or what's known as a 3-dimensional hole. And this is a 3-dimensional structural hole, because it's entirely within the shape. Okay, so we have 3 different types of structural hole. 1-dimensional, 2-dimensional, and 3-dimensional. But that doesn't quite feel right. Why is this 1-dimensional and this 2-dimensional if this feels like we've removed more stuff? Shouldn't that mean this should be a higher dimension of hole? The important thing is that we change how we think about holes. We're used to thinking about them as something that we can go through, right? So this has one way we could go through it, or we could also go up and down to go through it, right? This is just counting the dimensions of freedom, which is part of the space itself. Take this hole, for example. It feels like we have 1 dimension that we could go through it. But what if this is actually just a 2-dimensional shape? And there was a 2-dimensional person living inside? Well, then there'd be traps. They couldn't escape. And in fact, if we were living in 4 dimensions, then there'd be 2 possible ways that we could go through this hole. Counting the dimensions of freedom that we can go through a hole just isn't going to cut it. So instead, I want you to think of holes as the separation in an object, right? So instead of counting the dimension of freedom that we can use through the hole, we'll count the dimension of separation. It's like this is a 1-dimensional separation. And something like this would be a 2-dimensional separation. I think this is probably the thing that confuses the most people. It's so tempting to see a through hole and think, that's got to be 1 dimension because we can go through it. But in fact, it's actually a 2-dimensional hole. That's how we generally think about it. Or for example, a 3-dimensional shape then has 3 dimensions of separation. So that's why we call it a 3-dimensional hole. So, in total, we have 1-dimensional holes, which can either be structural or superficial. We have 2-dimensional holes, which can either be structural or superficial. And we have 3-dimensional holes. Okay, so where's a 3-dimensional superficial hole? Well, in order to make a hole superficial, we need to add a back on it. And to do that, we kind of need to go up into the next dimension. So in order to get a 3-dimensional hole, we need to put a back in 4 dimensions. And we're not looking at 4-dimensional holes in this video. That's a topic for another day. Also, now's probably a good time to note that, well, different people have different names for these holes, unfortunately. Like, I called this a gap. I don't know, maybe you'd call this a gap. Or I call this a through hole. You might call it a tunnel, but some people also might call this a tunnel. Or this I called a sealed space in the end, because I hope that avoided most confusion. Some people would call these cavities or pockets, but equally, these look like cavities and pockets, and English unfortunately isn't built around naming holes. But hopefully this gives you a good idea. Finally, well, counting holes in the real world is complicated. Like, you try and tell someone that this shirt only has 1, 2, 3, 4, 5 holes, and they're not going to be very happy with you. Or what about the gaps in between atoms? I mean, Minecraft is one thing, but the real world, that's a whole other kettle of fish. So, if you're going to remember 3 things from this video, 1, there are different types of holes. Hopefully, you can remember at the moment what those different types are. We have 2, there's difference between structural holes and superficial holes. Superficial just means on the outside. It's not a real hole, really. Structural holes are the one that we really care about. And finally, holes are a property of an object. That feels like a really strange phrase, but hopefully it makes some more sense now. If you're confused, think back to the knot we did earlier. It's not so much a place in space as it is just part of the knot itself. But basically, holes are complicated. Hopefully you can believe me on that now. But there is so much more I could say. I mean, in my opinion, things don't really get interesting until the 4th dimension anyway. But that's for another day. Hopefully this has given you some idea of what we mean by different types of holes. Thanks for watching, and goodbye.